Hi everybody, and thank you for joining me in this new short video presentation from ECG Exercises. I hope you will enjoy it and join me in my future video presentations. Thank you. For this week's ECG exercise, I chose a simple ECG in sinus rhythm to discuss together the atrial activation pattern after catheter ablation of atrial fibrillation. Our patient is a 76-year-old man with persistent atrial fibrillation. In past medical history, the patient received surgical mitral valve replacement and intraoperative AF ablation in 2006. In 2019, an 8-Watt Sapien 3 valve was placed interventionally in mitral valve position due to progressive mitral insufficiency. In 2020, he developed frequent palpitation. ECG showed left atrial tachycardia, and he was admitted to our center for catheter ablation. This is his ECG during the beginning of the EP study. A closer look at the ECG shows an atrial tachycardia with 2-to-1 conduction. This is also the same tachycardia with intermittent aberrant conduction with left bundle branch block pattern. And this is his ECG during sinus rhythm. This is the actual ECG which I wanted originally to discuss it with you. During sinus rhythm, with this example, I would like to discuss with you the application of the P-wave morphology to find out the interatrial conduction disturbances and also the pattern of interatrial conduction. So let's take a closer look at the P-wave morphology in limb bleeds. In limb bleeds, especially in AVF, we see clear distance between right atrial and left atrial P-wave and activation. So we have an interatrial conduction delay. Why? Because this patient received an extensive ablation on septum from the left atrial side and also received ablation in the region of Bachmann bundle. Normally we have an interatrial conduction which happens over Bachmann bundle, septum, and also the muscular fiber of the coronary sinus. In this case, so it looks like that the only connection between right and left atrium is through the muscle fibers in the coronary sinus. In lead 2, we have a left atrial P-wave which is almost isoelectric. In 3 and AVF, it is negative, and in 3 is more negative than AVF. So this is a sign that the activation happens through coronary sinus. Therefore, we have the most negative P-wave component of the left atrial activation in 3. So at the same time, we look at the P-wave of the left atrium in 1 and AVL, and we see that in AVL we have the most positive one, which is actually a finding that we should have expected. We have the most negative one in P-wave in 3. Therefore, we should expect the most positive P-wave in AVL. Therefore, analyzing of the P-wave morphology from the left atrium, we can conclude that the right to left activation in this patient only happens through the muscular fibers in coronary sinus connecting the right and left atrium. It is very interesting to see also that the lead AVR and lead 2 are perpendicular to the activation direction, and therefore the left atrial component of the P-wave in both leads 2 and AVR are isoelectric. I hope you like this short video presentation. I would like to invite you joining me here in my future presentations. Thank you.